9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
What's up, guys? Chris with Croft CNC for Newbies here. Just wanted to go live and show you guys some rotary setup stuff. We have there's two main rotary tables that people use, but there are a lot more availabilities, and what you'll find with them is you have to do a lot of math, and you have to have an individual setup for each one depending on how you plan on using it. So the main one that people use is this one, which is the Amazon 3 chuck. This is the K11, and this is the 3-jaw chuck version. And then there's the K12, which is the 4-jaw chuck version. Both of them are the same type of rotary chuck, rotary axis, just the chuck is different. You have a 3-axis or not 3-axis. You have a 3-jaw or a 4-jaw. Okay. You can get them on Amazon. They're pretty inexpensive. And you can go from there. So those are the basic gist of where everything is at with those. So typically you're going to have the let's see here, Amazon. I'm going to pull that back up just so I have it as reference for numbers. So when you get these things, you need to have some base settings for UC, CNC, or Mach 3 and whatnot. So I'm going to go ahead and open up my UC CNC, and I'll show you where we put them. Okay, so now I have my UC CNC set up. Let's move this over to here and down. Okay. All right, guys. So now I actually have my K12 rotary axis here. And then I have another version of a rotary axis. This is called a Trunnion Table. It actually has two rotary axes. It has one that would be considered an A, and then it has two which would be considered a B. So my table actually rocks back and forth, and this spins. That's for what is referred to as 5-axis machining. And you have to do these mathematical equations for both axes when you're dealing with the 5-axis. Okay. But the math is actually pretty simple. And I'll give you some of my settings that I like to use just to keep things simple. Okay. The very first thing you have to figure out is the pulses. The pulses required to do a 365 degree turn, and basically, let's see here. Okay, we're going to go 200 times 16 times 100, and we're going to put that in parentheses, and we're going to divide everything by 360. Okay, so all right, so now I can go to share. Okay, our pulses required. Having a hard time seeing because my glasses are polarized. Our pulses required are very simple. Let's see. Equals. Okay, so pulses required is the pulses for 360 degrees of rotation of your motor. Okay, that's the very important part of your motor. All right. Then you have to multiply that by your micro stepping. So if you have a 100 micro step or a 248 micro step or whatever your micro step setting is, 256, sorry, you would put that in there. So you have your motor turn pulses, your micro stepping, and then your reduction ratio. All right. So if it's a 100 to 1 reduction, then this is how, then you would take that whole number and you would divide it by 360 because you need 360 degrees. So these are the pulses that you would need to get to move your motor 360 degrees. Now this will change based on what stepper driver you use, what micro stepping you use, and what belt reduction you use for your resolution setup. Okay, so that'll be one formula, and it's basically your motor pulses times by micro stepping times by reduction setup. Okay, and then divide all of that by 360. Then we get into the good stuff. Okay, we need to set our steps per, and this is set up for each individual rotary table. So we have steps per 360 degree rotation times micro stepping. Okay, and that gives us one number. And then we need the 360 degree divided by the rotary table reduction ratio. Okay, so for our case, we're going to use a Gecko micro stepper set at 10 micro step, 10 spot micro stepping. Okay, so it would be all right, setting steps per, So we have stepper steps for 360 degrees times micro stepping. All right. Okay. And then that will be divided by the 360 degrees divided by reduction. Okay, so we have stepper, the steps per for the stepper, then times that by the micro stepping, and all of that is divided by 360 divided by the belt reduction, if there is any. Okay. This is where it gets a little confusing. This is where you start to lose people because there's a lot of math here. So we know we have a 200 actually. So we know we have a stepper. Sorry guys. This hurts bad. So all right, we've got 200 times 10 divided by 360 divided by 60 or divided by 6. I'm sorry. Okay, so we have a 6-to-1 belt reduction. And if you look on Amazon, let's see here, we can get all the information we need from right here. So we know that it has a 6-to-1 belt reduction. And then this is the pulses required for 1 degree of rotation. Okay. So all of that's right there. So now let's remove that. Let's go back to this. Okay, so from that, we know that our stepper motor gives us 200 pulses per 360 degrees. We need to take that into 10-spot micro stepping, and we know that it's a 6-to-1 reduction, so our 360 degrees of rotation needs divided by 6. So you end up with 2,000 divided by 60, and that equals 33.3 steps per degree. Okay, so now we have our settings for steps per that we can throw in there, and that'll get your rotary table actually stepping in the right setup. So now every time the motor turns 1 degree, the table can turn 1 degree. All right. Now comes the big part is the velocities. Okay. Velocity can be done a couple different ways. You can do it per part, or just do a regular roundabout, what works best for your rotary table and your machine. If you do that, if you just want a good starting number for velocity is 7,200 degrees per minute. Okay, that's a good starting area. You may have to lower it, you may have to raise it, but if you want to figure, you actually want the formula to calculate it, you have to take pi, which is 3.14, and multiply that by the diameter of material. Let's see here. We've got people. Wouldn't it be easier just to pay you to set it up? This is way more complicated. Billy Brown says that he doesn't want to go through all the math. Yeah, it would be easier to pay me to set it up, or just have me do the calculations and get back to you, or try different velocity settings and such. Okay, so if you do a velocity setting and a circumference calculation, so you're going to have your wanted speed divided by circumference. So then you have your wanted speed divided by the circumference times by 360, and that will give you your velocity in degrees per minute. So now, say you have a wanted feed rate of 78.75 inches per minute for a flat surface, right? You need to now turn that into a degree. Instead of flat, you need to turn it into a rotational calculation. So we would divide that wanted speed by the circumference of the part. So if we had a 5.90551 diameter part, okay, it would basically look like this. It would be 7.875 divided by 5.90551, and then you would multiply that whole thing by 360. Okay, and that will give you your needed velocity to achieve that speed. So if you go 78.75 divided by 5.90551 equals 13.335 times by 360, that gives you a velocity of 48,000 degrees per minute. So it will travel 4,800 degrees in 1 minute. That's the speed, the velocity, I should say. Now, I myself, I have found that this number here gets you very good. I've done a lot of research. I've watched other people's videos. I've done my calculations for the K11 and K12s. This is a great degree per minute setting. And then your steps per, back up to your steps per setting, that 33.333, that can be bumped up or bumped down based on a calibration that you perform of sending the rotary table back to a zeroing point. And what I did was I just put a scribed line on my flat and on the chuck, rotated it 360 degrees with that steps, and then got it close. So if it's a little bit over, drop your increase your steps. If it's a little bit under, or I'm sorry, if it's under, increase your steps. If it's over, decrease your steps. Okay. And then for velocity, I found that 7,200 degrees per minute is a good one. But like I said, with this particular setup, you're going to find that 4,800 degrees per minute would be the way that you would see it. All right. And the last number we really need is acceleration. Acceleration setting, a 500 degree per second is a great starting point for the K11 and K12. The formula is velocity divided by time in minutes equals degrees per second. So a 7,200 setting, and you divide that by 60 minutes in an hour, or 60 seconds in a minute, and that gives you 120 degrees per second. So it's going to, for every second, it's going to try and get up to 120 degree rotation setup. So when you do that, like I said, if you just use this starting number, and this starting number, those will actually get you right where you need to be for starting out for the K11 and K12. Okay. So now if we stop sharing that and we share our UC, and C, if you go up the configuration, you're going to be using an A axis. For those of you that have a slaved axis, you may want to change that to like a C axis. So change all the settings on this A axis to your C axis, and then put your A axis as your rotary axis. Your homing speed, it can be pretty much whatever Your step and direction pin, you're going to know that. If it has a homing pin, you're going to know that. Okay. Then you're going to set your steps per unit. So in our case, our steps per is going to be 33.3333. So 33.33333. Enter. Our velocity is going to be 7,200. Our acceleration is going to be 500. And then we don't need a soft limits. We can set that at whatever. We can turn the soft limit off for that. We can roll over 360 degrees. Our comp acceleration, you don't have to mess with that. Backlash, you can do all of that. You click that it's a rotary axis and you hit apply settings and save. When you hit apply settings and save, that will get everything to save into your profile. And then you can create a new profile that says rotary table. So you basically would go apply, save, then you could go to profile. As you can tell, I have a bunch of different profiles in here. You would load whatever profile, do your setup, and then you would go in here and you would name it rotary C4N 4896 RP and create. Well, before you do that, hit enter, then create and create new profile. And that will allow you to save a new profile in the UCCNC. So that is your roundabout way of setting up your rotary table, that if you wanted to do anything, you could go from there. Now, we are going to break this into a couple part series, and we are going to do rotary carving with the spire. So I'll show you how to set that up. And then I'm going to carve stuff with the rotary table and show you kind of what the outcome was. So let's see here. Okay. But that was one of those real technical morning setups. So it's not easy to get the math down, but once you get the math down, you can really dial in your rotary table and you'll get great cuts. It will take you a little bit to dial it in, but once you get it dialed in, you'll have all your numbers saved and you won't have to worry about nothing. All right. All right, guys. With that being said, I'm going to cut you out and I'll talk to you later.